Number 1. Write an equation in slope-intercept form of the line that passes through the given point and is parallel to the graph of the given equation. And write that equation in slope-intercept form. So let's do that. Now, parallel lines have the same slope and they never intersect. The first step is to find the slope. The slope of the original equation is -5. That's also going to be the slope of the new one because, like we said, parallel lines have the same slope. Second step is to find b. To do that, we substitute our slope in for y equals mx plus b, which is -5, and substitute in our point that it goes through in for x and y. So y is -6, x is -5, so we have -5 times -5, which is positive 25. Subtract 25 on both sides, and we get -31 equaling b. Now, the third step is to put m and b together for y equals mx plus b. So m is -5, so y equals -5x minus 31 for my b. And that's the answer, so let's type it in. Y equals -5x minus 31. And that's the answer for number 1. Number 3. Find the equation of a line that is parallel to the line x equals -14 and contains the point -2, 4. Now the line x equals -14 is a vertical line, and every x coordinate is -14. Lines parallel to vertical lines are other vertical lines. So if it goes through this point, then it has to have the same x value, so the equation is just going to be x equals that x value of -2. That's number 3. Number 4. Determine whether the graphs of the given equations are parallel, perpendicular, or neither. Looking at the slopes of the lines, they're different, so they're not parallel, but they are opposite reciprocals. You flip one upside down, you'll get 1. Opposite means opposite signs, you'll get -1. So 1 and -1 makes it perpendicular. And that's the answer for number 4. Number 5. Determine whether the graphs of the given equations are parallel, perpendicular, or neither. We have a horizontal line and a vertical line. Their intersections are always perpendicular to each other. So it's perpendicular for number 5. Number 7. Write an equation in slope-intercept form of the line that passes through the given point and is perpendicular to the graph of the given equation. Now the first thing we need to do is find the slope. The slopes of perpendicular lines are opposite reciprocals, meaning flipped upside down and opposite signs. So the original slope is -4. Flip it upside down, you'll get -1/4. Change the sign to positive, you'll have +1/4 as the new slope. Step 2 is to find b. So take that new slope and put it inside for m, and put in 0, 0, our point, in for x and y. So that we multiply 1/4 by 0, we get 0, so b is going to equal 0. So step 3, put our slope and our y-intercept together in y equals mx plus b. So we have y equals 1/4x plus 0, which we don't write. So let's type this in. So type in 1/4x. And that's number 7. 9. A path for a new city park will connect the park entrance to Main Street, as shown to the right. The path should be perpendicular to Main Street. What is an equation that represents the path? The first thing we need to identify is the point that the park entrance is on. That is 0, 3. The next thing we need to identify is the slope of this line, because the line we're looking for is perpendicular to it, so we need the original slope first. So starting at this point and using this point, I'm going to count up, which I count up 3, to the right 1. So rise over 1 will be 3/1, so my slope's going to be 3. So perpendicular to that, I will flip the 3 upside down and get 1/3, change the sign, it'll be -1/3. So that's going to be the slope that I need. Now all I have to do is put both of these into slope-intercept form because this is the y-intercept. So I'll have y equals negative 1 over 3x plus 3. And then that's going to be the answer. Type in negative 1 over 3x plus 3. And that's number 9.